Mm.
So yeah, hi everyone. I am Anirudh Gupta, and along with me is Lovejeet Singh. We are from HSC, and we are here to discuss a use case to support O1 interfaces in ETSI OSM for RAN slicing. So let's just quickly move to the agenda. So this is a top level agenda that we have for today, in which we'll cover the 5G end-to-end network slicing, followed by the ORAN architecture, and then what flows and integration we have followed to communicate between different entities. And at the last, the enhancements to the HC OSM for this line slice support. So these all will be covering in the next few slides. So okay, so talking about 5G networks, this end-to-end slicing enables operators to basically partition a single 5G infrastructure into multiple virtual networks with guaranteed performance, security, and resource isolations across these across the different domains like RAN, transport, and core domains. This is done to support diverse services like IoT or mission critical connectivity and enterprise applications as well. So these are some of the common applications. These basically slices, what they do is they help the 5G services categories. There are different categories like EMBB, enhanced mobile broadband for it is required for high speed data and bandwidth intensive applications. URLLC, that is ultra reliable low latency communication for real time safety and critical use cases such as autonomous system or industrial automation or health sector. These can be some examples under it. And the third part is a massive machine type communication, that is MMTC, for basically large scale IoT deployments. So in these things, this is of a great use. So we'll be discussing about these in the next slide. So when a customer requests a service from any OSS BSS layer, so basically it just a second, I'll just point a point. Yeah. So when a customer requests a service from the OSS BSS layer, it is consumed by the CSMF, that is Communication Service Management Function. The basic task of this CSMF is to interpret business level request into a technical requirements for the corresponding network slides. Okay, so this output is then passed on down the layer to the NSMF, and which orchestrates and manages the life cycle of the end-to-end network slice across the multiple network domains. Further to the lower level, the end-to-end slice is decomposed into the multiple network slice subnets, each managed by a network slice subnet management function, that is NSSMF. So, for example, RAN, transport, or core subnets, these can be part of this NSSMF subnets. These ensure the resource allocation, configuration, and scaling at the domain level. These all responsibilities are of NSSMF. So currently our focus would be to discuss on the RAN subnet. So moving ahead. Yeah. Okay. So this is the ORAN architecture, which is it has a service and management orchestration, which plays a vital key role in managing, configuring, and optimizing the ORAN components. Basically, it leverages the automation and AIML and intent-driven orchestration. All these tasks are this it comes under this SMO framework. So it has three major interfaces. This O2 interface, A1 interface, and O1 interface. So on these three interfaces, basically this O2 interface is used for infrastructure management, that includes onboarding and orchestration of applications or the workloads onto a particular Vim. So Vim can be OpenStack, Kubernetes, Tacker, any Vim that is supported can be a part of this O2 layer. This actually interface allows this SMO to manage the manage the resources, health monitoring, and scale down the workloads dynamically. So next we have is A1 interface. So A1 interface primarily is responsible for policy management and intelligent control. So it enables the policy driven optimizations and supports the AIML models. for traffic sharing. Next is the O1 interface. That is the O1 interface that we are working on. So it is a netconf or Yang based interface, which is used for configuration management, fault monitoring, performance reporting, and it can some software updates of the RAN elements. So all these RAN elements, OCU, CP, ODU, and ORU, all these are the RAN elements that can be managed. So for this use case, we have taken OSM as an orchestrator, and our focus is to development of this O1 interface to configure and interact with these RAN components. This would be done using a netconf interface, netconf server on the O1 interface. Yeah. So as you can see, this would be the area of work for us. So we are also using 3GPP compliant RAN software stack that is provided by OAI, Open Air Interface, which delivers the open implementations of all these components, OCU, CP, OCU, ODU. These components actually are aligned with ORAN standards and are designed to integrate seamlessly with any virtualized RAN ecosystem. So each network function has a support for a network for a netcon server, enabling the configurations, lifecycle management, and monitoring through external orchestration via this O1 interface only, which ensures the interoperability and automation across the network. However, the currently provided Yang models in OAI are still under development, are still evolving, and they offer a partial feature support only. So the current challenges that we have currently, like as we discussed, we need to develop the support for the O1 interface in the HC OSM. And although there are some open source solutions like ONAP, which do have these capabilities, but they relatively have a larger footprint, and they have a very sharp learning curve, because of which we are more focused towards the HC OSM Mano. Again, there are some proprietary solutions as well, like with some top giants like Ericsson and Nokia, which do provide these capabilities. But again, they come with a license cost, and the source code either is not accessible or a very limited access is there to the source code. So these are the current challenges that we have encountered, and for the enhancement of these to encounter these challenges, we have developed our strategies to develop this, for which I would request Lovejeet Singh to further take over.
Yeah, thanks, Anirudh. I hope I am audible.
Yeah.
Yeah. So, to further discuss with the flow and integration, in this slide, we will discuss the high level flow, where we having open slice, OSM and OI, that is the RAN stack, where open slice is used as an OSS by the customer for the service ordering, and OSM as an orchestrator, which further will interact with the Vim, that is Kubernetes in our case, where our actual RAN components that is provided by OI will be deployed. The service parameters, if we talk about the service that is ordered from the open slice, the service parameters like availability or the quality of service, etc., these values will be declared by the customer at the time of the service order, and passed to the OSM as an additional parameters under OSM config. So with the network service creation request, so once whenever any user creates the service order, these parameters will to be filled by the customer, and that service order then triggers the network service creation request to the OSM. So these parameters will goes along with this request in the one of the parameter of the OSM called OSM config, and then further in the OSM, as these parameters are in the form of nest attributes which are not understandable to the RAN components directly. So OSM here will need to do two major tasks. That is, first is to translate these nest based attributes or values to the 3GPP compliant attributes, which actually will be understandable to the RAN components. And further, we need to push these attributes to the RAN components, that is via netconf. So that is via O1 interface only, so which we needs to be developed. Okay. Moving to the next slide, we will discuss the detailed design here. Okay. So to extend the last slide, here we have developed a detailed design where we having again three major components, that is open slice here, OSM and Kubernetes, which are already deployed, and also Kubernetes having open source netconf operator deployed, which is extending the capabilities of our Kubernetes by providing the extra CRDs, and these CRDs are responsible to create the Kubernetes resources, which will be created at the time or whenever we need to interact with the ORAN components and we need to edit any configuration via netconf. Okay. So in OSM, we have added the Kubernetes cluster as an Vim, and we have added the ORAN Helm chart, which are provided by OI for the deployment of our deployment of ORAN components. So if you see the open slice part, where the service designer already created the service which needs to be deployed the ORAN components which having configurable parameters, and these parameters, as we discussed, has to be passed to the OSM via additional params. And we have defined some of our introduced our 5G parameter structure, and open OSM config actually is a dictionary, we can say, or JSON type structure, and we have added the some of our parameters. We have extended this dictionary to add our 5G parameters there. Okay. So OSM, okay, we have in the OSM, if we once the parameters are there in the OSM, we have to parse these next parameters, and we have to develop the functionality where we have to process these parameters. We can say RAN, network service, NSSMF, or we can say param processor, whatever the name we need to do. And what it will do is once these parameters are with the OSM, it will actually convert these parameters from nest to the 3GPP compliant parameters, which actually understood by the RAN components and actually stored it in the DB. And along with that, it will also launch the OSM that is natively is deploying the Helm chart, and a Helm chart is again deploy over ORAN components, that is use DU or RU, whatever the components there will be. Okay. And once these components got deployed and these parameters got processed and stored in the database after the conversion, we having next module, that is a param applier, and we can say that is the netconf gateway kind of stuff, which actually needs to be developed with the support of as an gateway to the netconf operator, which actually get the port IPs from the ORAN from the for the ORAN components from the Kubernetes, and tries to trigger the netconf connection. And once it is successful, it will get the converted parameters from the database converted into the Kubernetes resource definition based on the provided by the netconf operator, and accordingly push the configuration to the ORAN components. Okay. That's the actual way out how this all will to be worked actually. And if you having any questions, please let me know. Then I will let you know what actually we have, what are the components we have tested as of now, and what are still in the progress. Okay. Okay. We have tested so far is we have tested that we are able to uh, create the service with the configurable parameters in the open slice, and we can pass these parameters which are defined by the customer to the uh, defined by customer, and these parameters get passed to the OSM using the OSM config, and we can convert these parameters. And secondly, we have also tested that netconf operator part, that we have compiled the netconf operator, that is open source also, and we have compiled it, and we have tested the functionality, and we have tested that it can trigger the connection and it can configure the resources whatever we need. Okay, so what we have to test is we have to now write the param processor, that is RAN network slice subnet management function, and that is param processor. Actually, we have to develop that. That is, we have to develop the mapping from next to 3GPP parameters, and next the param applier, that is how it will get the IP of the ORAN components from the Kubernetes. That we have to check, and then we are good to go with all the stuffs with the design. Moving to the next slide. If you're having any questions, then we can discuss it in the design. Okay. So here, as we discussed, we have introduced some of the parameter in the OSM config that has to be passed from OpenSlice to the OSM. We have introduced the additional param for 5G, where we have that is highlighted in the green, where we having a RAN as a subsection, and again we having CU, DU, RU, and the whatever the values which needs to be passed, that will be passed using this structure. And along with that, we having core and transport, and that can be supported for that are there for the future purposes if required. And using this way, we can get the values from OpenSlice to the OSM, and OSM will actually process these values, convert these values from next parameters to the 3GPP compliant, that is over RAN and NSSMF. Actually will do it, then accordingly our netconf gateway, that is param applier, will accordingly apply the configurations to the ORAN components. So that's it from my side. Please let me know if you're having any questions, anyone.
Thank you very much, Anirudh and Lovejeet, for this nice presentation. Is there any questions for Anirudh and Lovejeet? Yes,
Thanks, man.
Hello.
Go on, please.
Yes.
Okay, perfect. I would like to ask you, can you elaborate the differences when you create with the Helm chart the run functions and the configurations that you do through this netconf operator? Some examples of the actions of the netconf operator.
Okay. So Helm chart, OSM is traditionally doing their work right now. That is, it is actually deploying any of the network services or KNFs, that is Kubernetes functions to the Kubernetes right now also, but actually it is not configuring it via netconf. So with the help of netconf operator, we can do it. Right now, I think I don't have a example handy. I have in my lab as well, but I will get with the examples to you. But that is the actual work that OSM is doing. That no, that is traditionally it is doing with the Helm, and it is doing the instantiation of the network services on the Kubernetes. But again, the O1 interface, that is with the help of netconf, as our RAN components having the netconf server, and with the but OSM is not doing their work to configure it via the netcon. So we are doing we are developing that capability in the OSM to integrate the O1 interface here. And we having a netconf operator is giving us some of the CRDs, that is, and we can create, these are easy YAML files. Then with the help of these YAMLs we can get interaction with our ORAN components, just like we having pod YAML. If you are aware about the Kubernetes, we having pod YAML to create the pod in the Kubernetes, and we having some other stuffs. And similarly we having netconf based YAMLs provided by the netconf operator, and using these we can interact with the components. I hope I answered your questions, although I will get back with you the examples. uh,
Okay, thank you. Just to follow up, with Helm chart, you deploy a container, and you can
yes,
also reconfigure it if you update the config map, for example. So
yes,
I'm
yes,
trying to
correct.
understand
Yes,
why you don't
yes.
do the netconf configuration through Helm chart updates, but you need a separate component. I don't know, I'm not aware of what are the netconf operations. If you can give an example, why you
Okay,
need netconf configuration? What do you
okay.
configure in the run elements?
Okay, so netconf can do a lot of stuffs, but right now we are only focusing that we have to configure it only. It means we have to deploy some configuration on it, but even it can be used for the to get the matrices and all other stuffs as well. But as of now, we are only focusing that firstly initially level to configure the ORAN components with the help of netconf. But yeah, you are right that we there is a way to do it from the by updating the config map only. But as per as we discussed in the uh, slide, we having ORAN architecture, and we having support of O1 interface there, and there is a some way and some standard to do some stuffs, and that's why I think we have to follow this path only.
Yeah, just to add on this, basically the netconf is used for other purposes as well. Like we can do get configs and edit configs. We can push the configs. And talking about this O1 interfaces, why we have gone through with O1 interfaces, because this is when it provides vendor interoperability and openness. And basically, we can also have the performance monitoring and telemetry stuffs using this O1 interface only. And also these fault management, all troubleshooting, lifecycle management, all these can be managed using this O1 interface. So that's the reason we wanted to go with O1 interface, so that it can remain open to and vendor not vendor specific.
Thank you.
Thank you.
Yes, Kostis?
Yes,
Go.
cost.
Hello, thank you for the presentation. Just a quick question out of curiosity. Have you found any limitations in the nest, in the GST template, regarding your use cases? Any property that you actually wanted to see there and it was missing?
Okay, in the next attributes or in the 3GPP compliant. Uh,
No, in the nest, in the highest level.
no, not at this stage. We haven't found that as of now.
Okay,
Yeah.
thank you for the answer. Actually, I'm just asking, taking the side of the OSS, so to know if we need to extend somehow, the parameters
Hmm.
to
We are
facilitate any other
actually
needs.
only trying the top level next attributes as of now, means for the POC purpose, but might be you are saying that you have to extend it, but at the top level I haven't found that much.
Mhm. Okay,
Mhm.
thank you.
Yes.
Okay. Thank you very much, Lovejeet and Anirudh. So if you want to know more about open source Manu, and please visit our website. And if you have more questions, don't hesitate to contact Lovejeet and Anirudh. Thanks again.